All right, so this is going to be another optimization problem. The only difference is that we're actually going to work with it within a context of an actual situation, right? So now we've got this farmer. He's got 300 feet of fencing, and he wants to enclose a pen, right? Now we want to say what dimensions would yield the greatest area, right? Well, in order for this to be able to work, a pen, if you're going to enclose, it's like for cattle or any kind of farm animal. We're going to draw out our pen. Now, we have dimensions. Obviously, it's going to be a rectangle. We've got these two dimensions, x and y. Now, you don't have to use x and y. You can use L and W, length and width. By the way, that's what we're going to be working with. Now, there's two things that we're going to be working with. First off, we know how much feet of fencing he's going to have to use. So what that really ends up dealing with is your perimeter. So I have to write out my perimeter. That could be 2x plus 2y is equal to 300. All right, so we know how much fencing we're going to use to enclose this pen. Now, the other thing is our area. So we have an area function that we want to maximize, and this area function becomes x times y. So like the previous one where we had two functions that we were working with and we had to use them simultaneously, it's the same idea. We're going to go ahead and solve for one of our variables. I'm going to solve for y. You're going to see y is equal to 150 minus x. And then we're going to do the exact same thing that we did earlier in that previous video. We're going to go ahead and do some substitution. I'm going to distribute again. And since we want to maximize, we do have to figure out our derivative, set it equal to 0, and just make sure that the value that we find maximizes it. So I'm going to take my derivative. I get 150 minus 2x. I'm going to set that equal to 0. You're going to find out 2x is equal to 150 and x is equal to 75. Now, as always, I'm going to go ahead and check this out. So I'm going to use my little chart here. Here's 75. I know I get 0. I can use 10. I can use 100. If I plug 10 into my derivative, I get a positive number. 100 gets me negative. So this does, in case, maximize it. So now we're going to go ahead and plug that in there. I get 150 minus 75. So I end up getting y is also equal to 75. So in order for us to use that fencing properly and also to maximize that area, we both have to have 75 feet of fencing along every single side. So it ends up becoming a square. All right, but that's another way that we can optimize using two different equations. We had to come up with these two equations and then use them properly.